public key and private key to do the digital signature with the hash functions. In today's class, we'll try to discuss a few of the important parts that how it applied in our digital signature in the public key cryptography. So as we discussed that in previous slide, that by signing the message using the private key, then only it gives to your digital signature. Signing with the public key, it can be used for your encryption purpose, but if any message, if it is encrypted with the private key, that will give you the digital signature. So suppose if you have the the Alice and the Bob here, if they exchange the information, that means only Alice can know the private key of her own, and the verifying the signature of the Alice by using the public key of your Alice by the Bob on receiver side. So everyone has the Alice public key. How this key is distributed, that we will discuss in this today's lecture. So Alice public key will be there with every node in the every legitimate receiver who has the public key of your Alice. They can simply verify the signature. So in this process, if Alice wants to send any information in terms of transactions or anything, then that information we treat as a message. That message is signed by your Alice with her private key by doing the same procedure as we have a message. That message goes through your hash function that will generate a digest, and that digest is encrypted with the private key of your Alice. So that will generate the digital signature. Then the digital signature will be concatenated with the transaction and will transfer. But in this public key cryptography, as said, the message along with the message is encrypted with the private key of Alice, so it will generate the signed message, and that signed message will be transferred to your Bob. So Bob will verify the signature by using Alice public key. So using Alice public key, they can decrypt the message and get that message for the what is there inside the message will be checked by your Bob. So this will reduce the by reducing the signature size, suppose. So they use the message digest as we discussed to sign instead of the original message. So that we have observed that the message goes through the hash function, and that hash is encrypted with the private key of your Alice, and that will generate the signature. Then this signature along with this message will be transferred and goes through the network to a destination side, and destination side Bob will verify that he will decrypt by using the public key of your Alice. So is decrypting only the signature, not the entire message. And then you will get one digest. That digest is compared with the message which goes through the same hash function. If that digest is matching, that means it is accepted. If not matching, it is the vulnerable one. So in digital signature, how it used in the blockchain means it is basically used to validate the origin of your transaction. As we discussed, if the digital signature is there, it can validate the confidentiality, integrity, and your authenticity. CIA. So it prevent the non-repudiation in the blockchain technology by using this digital signature. So that is, Alice cannot deny her own transaction that this transaction is not generated by me and I'm not responsible for that. That cannot, because that message is signed by the Alice private key only. So no one else can claim that Alice transaction has as his or her own transaction. It is so in Bitcoin. to generate the digital signatures, as we saw the digital signature algorithm, RSA algorithm, and your elliptic curve digital signature algorithm is there. So in blockchain, in Bitcoin technology, in Bitcoin they use the elliptic curve digital signature algorithms. So that is based on the elliptic curve cryptography, and that supports the good randomness in the key generation. So we don't go in deep about that. But in cryptocurrency, it uses the hash chain, as we discussed in the previous lecture, previous classes, that in hash chain, if Alice is having, suppose, or generates 10 coins or 15 coins, so whatever number of X number of coins, so those coin is one transaction. Alice is having 10 coins is one transaction, and we treat this as your message. This message goes through the hash function that will generate one digest, and that digest is encrypted with the private key of your Alice. So that is the private key of your Alice. So it will give you the encrypted form, that is the signature of your Alice. Now this signature along with these transactions, so that is sign the transaction of this. Alice is having 10 coins by private key, and put that in the blockchain, and that can be used by the any other users. So how it will be done in hashing means, as we saw that the every block is having 4 fields. One is the previous hash field, and having the Markle root field, timestamp, and the data part. So that data part of your block is used to generate the hash of next block. So when Alice trying to transfer 5 coins to Bob, what Alice do? Alice will initialize the hash value by 256 initialize vector of your hash value, and then in that it generates the hash, and in the data field it is having the transaction, that is the message and the digital signature. So this can be distributed in the blockchain. So from this, the next block Alice is generating, because upon doing the first transaction that Alice is trying to transfer 5 coins to Bob. So from here, from 10 coins, Alice is transferring 5 coins to Bob, and for this the hash is generated. This hash is based on the message and signature of the Alice. So H1 will be generated. In that hash, it is giving that the 5 coins to Bob, and that transaction is signed by Alice. So this signature will be decrypted. This signature will be verified by Bob, whether this transaction is from the Alice or not. So as soon as it is verified, then Bob will use that transaction to check whether the 5 coins are received or not in Bob's account. So there, the Bob is using Alice is using private key and put that in the blockchain. So this process continues as if the Alice send another 5 coins to any other users in the network. Then Alice will generate another hash, and suppose Alice will send to some Tom, suppose the 5 coin, then it will generate the sign of A, and this block is the exchanged in between the Alice and Tom. So this is the cryptocurrency using the hashing with the digital signature, one of the application of that. So in this case, maintaining in the hash chain and the digital signature, maintain the economy that that gives the generate a new coins with time. So as we said, in blockchain, it maintains the previous hash component will be there, and timestamp will be there. And then you will have the Markle root. and the data part to generate the next hash for the next block 1, suppose it is, if it is block 0. So every time in the cryptocurrency, they have to maintain the new coins with the time period. As because in the first, initially Alice is having 10 coins. After doing one transaction, Alice will have only 5 coins. After doing another transaction, Alice will have the 0 coins. So that is, the older coin should be deleted and the new updated information should be there. The new transaction would be required in this. So a central authority like the bank can create and destroy coins based on the economic policies. But in this blockchain technology, the crucial question is how can we distribute the coin management, that creating and destroying it. So by creating the coin or destroying the coin, it requires to verify the digital signature. So to verify the digital signature, your sender or receiver, they must exchange the key. So how to exchange this key? So that exchanging the key, we call that distribution of your keys. That is, there are some authorities, trusted authorities will be required in this public key infrastructure trust system to exchange the keys. So how it will be exchanged then? So the authorities in this public key infrastructure system, that if you see that the analogy of the driver's license, first the applicant or the Alice applies for the driving license to the authority or the agency which gives the driving license. So then upon when Alice goes to the authority, they will verify the identity of your Alice, and then she will receive her driving license after her identity is proven here. So one certificate is given. That certificate is digitally signed by this authority. So Alice attempt to cash a check, suppose. In that case, her identity is accepted after the driving license verification to do any the cash transaction. The same way, in the to establishing any asynchronous connection means in the digital signature by having two different keys between two hosts, the host will exchange their public key information. So how to exchange their public key information with the trusted parties? So the trusted third parties on the internet they can validate the authenticity of these public keys of your Alice or Bob or Tom or anyone using the digital certificates. So these third parties issues the credentials that are difficult to forge, because these trusted parties means every user in the network should go and get the digital certificate from this trusted party. So from that point forward, all individuals who trust the third party, they simply accept the credentials that the third party issues, the digital signature. So in this public key infrastructure that consists of the specifications for identification purpose and the system which is used, that is whether the single tier system or multi-tier system in certificate issuing authority, and tools that are used to create these digital certificates, whether they are using the RSA algorithm or your secure hash algorithms, whether they are using the elliptic curve algorithm or digital signature standard. Those tools will be used, gives information of that, and they manage those, distribute these keys, and use those keys for the encryption purpose and decryption purpose. And at the same time, for every certificate which is assigned to any individual, then it gives the time period. Within that time period only they can use that certificate, like 6 months or 1 year. After that, that certificate will be automatically revoked. So again, new signature is required. So to go through this process and complete the public key management, there is a certificate authority which creates the digital certificate by tying a public key to confirm the identity of your sender, such as it may be any individual or it may be in the website. But in blockchain technology, this creates a digital certificate for individuals. So what happens in this infrastructure for any individual? They wants to participate in the or exchange the key in public key infrastructure certificate. They in PKI certificate that contains the entity or individual, any individual or any entity. So it may be any website or any organization, that the individual's public key first it defines for what purpose it is required, and the identity of the user will be given to the certificate authority. So that identity of any individual user is encrypted by the key public key, the private key of this certificate authority, and that will give the signature. That signature goes to the user. Then user can use the public key of this certificate authority to check what is there inside this identity and check the new digital sign. So the certificate authority that validates and issues the certificate that the data range during the certificate is valid. And after that, certificate store resides inside the local system. They can use that one for the encryption purpose and the the decryption purpose. And the certificate authority is the trusted third party as discussed. So this certificate database stores all certificates provided by your certificate authority that will be there in the certificate database. So how in this diagram you can see this. When Bob and Alice they wants to exchange some information, then the certificate authority issues a digital certificate to Bob. Then Bob use that digital certificate. So that is initially requested certificate from this authority. So CA the authenticates that Bob and the Bob's keys, the private key and public key in that certificate, verifies from this database and issues the PKI certificate, that digital certificate given to your Bob. So then they exchange this public key certificate. Bob will exchange the public key certificate with Alice. So then the by using the that certificate, digital certificate is encrypted with the private key of your certificate authority. So once it is received by the Alice, then Alice verifies whether the key which is exchanged, the key of public key of your Bob which is exchanged between with this Alice is correct or not. So for verification purpose, whatever the PKI certificate is received by Alice, that sends to the central authority. So central authority decrypt that using the certificate authority's key and check whether that is the certificate which is given to Bob is there or not in the database. If it is there, then it says that it is valid, which is issued by the certificate authority only. So in that certificate authority, in that way, Alice will get the public key of your Bob. So after that, when Bob sending any message with the digital signature, so that digital signature is decrypted by the Bob's public key, and that process is continuous. So in this public key authority system, The many vendors provide the certificate authority, servers as a managed service or as an end user product. So the organizations may also implement the private key and public key infrastructure using the Microsoft server or your Open SSL to generate the private key and public keys. So the certificate authority issues the certificates based on the classes which determine how trusted a certificate is. So what are those classes? If it is class 0 means that digital certificate is used for testing in situation in which no checks have been performed. If the digital certificate having the class suppose 1, which is used by individuals who require the verification of emails. If it is class 2 means used by the organizations for which the proof of identity is required. If class 3 means used for your servers, class 4 means that is used for business transactions. So in the blockchain technology, the class 4 is used for business transaction purpose, and 5 is used for private organization, that is permissioned blockchain technology or permissioned Bitcoin technology. So any enterprise that can implement this PKI, but that class number is determined by how rigorous the procedure was that verified the identity of the holder. So the higher the class number means the more trusted the certificate. If lower the class number means they are the more less trusted certificate authorities. So some CA certificate authorities public keys are preloaded, such as those listed in the the web browsers if you go and check in that. So in this public key infrastructure system, PKI performs different topologies for the trust, which are known as your single root public key or cross-verified technology or your hierarchical technology. So in single root means it is the simplest one, and the single root topology, the certificate authority directly issues the digital certificates to the end users in that network. Only the certificate root can assign. But whereas in cross certificate authority, here the subset authorities will be generated. They can use the root key certificate where it is having the root keys, public key and private key, that is used to generate the sub keys. So it is a peer-to-peer model, so which is connected to one-to-one. It can, this certificate authority can generate these sub digital certificates to issue in that particular group, so that it will reduce the load of your root certificate authority. So whereas in hierarchical certificate authority, it follows the binary or Merkle tree certificate authority structure. So root can having the highest level of your certificate authority. So that will issue the digital certificate to the sub certificate authorities, and these sub-domain authorities, they can distribute the they can give the certificates to other users in the network or end users in the network. So these are three different ways of distributing the keys, the digital certificate to various users to verify their identity with the certificate authority. So in this case, everyone first needs to enroll their certificate with the central authority. So in this enrollment process, the authentication will be done by your certificate authority. And finally, for every certificate, only certain time period is given. In that time period, they can use that certificate, or else the certificate will be goes through the revocation process. So as said, the all systems that they leverage the public key infrastructure system for key distributions, and they must have the CS public key, certificate authorities public key, so which is called the self-signed certificates. So for the certificate enrollment, every user, their identity is encrypted with the public key of your certificate authority, and that will generate a signature. Okay, not digital signature, a signature. So this will send to the certificate authority. Now certificate authority use the private key of survey, the private key of certificate authority to check the identity of the user, and CA's public key that verifies all these certificates which is issued by your CA for the proper operation of your public key infrastructure. So the certificate enrollment process is used by the host system. So what is there in the identity says that this is Raj having my private key of R, public key of R, and this is encrypted with the public key of your certificate authority, and that encrypted message sent to your certificate authority. So certificate authority decrypt this and maintains that the identity is Raj, having private key is Raj and public key Raj. So in the database of your certificate authority database, in this database it maintains the stored certificate. The entries are Raj having private key, the identity, private key, public key. The entry is Raj, private key is suppose 11, public key is 23. And once it is verified and stored this data in the database, now this is the entire message will be digitally signed by the certificate authority and send it to your the sender. So now that is digitally signed. This entire message, let us assume this is entire message. It is digitally signed. Means what? This message goes through the hash function of your certificate authority. It may be your SHA256 suppose. It generates a digest. That digest is encrypted with the private key of your CA and send this digital signature. It generates a digital signature. That digital signature and this message is having Raj, private key and public key. So M and S send back to the user, suppose Raj. Now this will be exchanged with the receiver, any of the receiver. So upon the exchanging of this information, the receiver can decrypt and check that what is the private key and what is the public key. But when exchanging this, in that message, the private key is used by your sender, so that field is removed from the message. So Raj and public key and the digital signature by your CA will be sent to your Alice. So upon receiving this, to do the signature verification, Alice will send this digital signature to your certificate authority to check it out. So that is what happens in this. So the system enrolling the PKI contacts of your CA to request and obtain the digital identity certificate for itself. and to get the digital certificate, self-signed certificate. So then the final stage, it verifies the CS certificate by using authentic and performed using the out of the bond method, such as the POTS, to obtain the fingerprint of your C identity. So then the digital certificate can be revoked if key compromised or if it is no longer needed by the sender or receiver in the blockchain. So here only a root certificate authority can issue the self-signed certificate that is recognized or verified by the certificate authorities within the public key infrastructure. So this is how we use the key distribution. So keys will be generated by the individuals, and they have to enroll their certificate, that digital certificate, with the third party, trusted third party. Trusted third party gives the digital certificate, public key digital certificate. That digital certificate is used to exchange the key. In that digital certificate, the user's public key and their identity will be there. So that way, the public key is exchanged with the trusted parties in the network. So this is what we use some of the